You know when you're cramming for a test, do you kind of just naturally picture your memory as this biological filing cabinet? Like you open a drawer, shove a bunch of facts inside, slam it shut, and just cross your fingers they stay put until exam day? That's a comforting thought, right? But the scientific reality of human cognition is far more fascinating, and honestly, way messier than simply locking files away in a mental box.
Welcome to this explainer. Today, we're going to totally shatter that memory box myth. We're going to do that by bridging a foundational cognitive psychology paper from the 1970s by Craik and Lockhart with a modern 2015 study by Dr. Sami Alanazi. And this is going to show us exactly how these processing principles actually impact real-world language learners today. Here is our roadmap for today. We'll be covering the memory box myth, depth of processing, testing language knowledge, the hot dog problem, time, guidance, and results, and we'll wrap up with rethinking human learning. Let's dive right in.
Section 1. The Memory Box Myth. Breaking down the multi-store model.
So for a really long time, the scientific community relied heavily on what's called the multi-store model. This model neatly categorized memory into sensory, short-term, and long-term boxes. Think of it kind of like a factory assembly line. The theory went that information comes in through your senses, gets held for just a bit in a short-term store, and then if you rehearse it enough times, it magically transfers into a permanent long-term store. And for over a decade, this was the absolute dominant way researchers tried to explain how we remember things.
Now, this box approach was incredibly attractive because it just felt so logical, you know? Information supposedly flowed along these well-regulated, predictable paths. Short-term memory was seen as this tiny little box holding information strictly by its sound, phonemically, for just about 30 seconds. Meanwhile, long-term memory was viewed as this vast, limitless semantic vault, organized entirely by meaning, where information could just hang out for minutes or even years.
But those neat little filing cabinets eventually started breaking down under scrutiny. Researchers started realizing that these boxes are fundamentally flawed. Why? Because our memory capacity and forgetting rates actually vary wildly depending on the specific material we're analyzing. Craik and Lockhart pointed out some super glaring inconsistencies here. I mean, if the short-term memory box is so incredibly strict, why could it only hold, say, 2 to 4 random words, but it could easily hold a massive 20-word sentence if those words formed a meaningful thought? They also found that short-term coding could be visual or semantic too, not just phonetic. So the whole box analogy was definitely springing some major leaks.
Moving to Section 2, Depth of Processing. It's about how you analyze, not where you store.
Here is the real game changer. Memory isn't about rigid storage containers at all. It is entirely about processing. Craik and Lockhart proposed a massive paradigm shift. They argued that retaining information is actually just a byproduct of how deeply you analyze and extract meaning from it. So if you just passively look at the physical features of a word, like the shape of its letters on a page or the pitch of someone's voice, that is shallow processing, and that memory trace is going to fade incredibly fast. But if you deeply process it, by matching it against past learning, recognizing underlying patterns, and extracting its true meaning, you create a much stronger, longer-lasting memory trace. You aren't moving a file from a temporary box to a permanent one, you're simply analyzing the information on a much deeper level.
Section 3. Testing Language Knowledge. Applying Cognitive Processing to Saudi EFL Learners.
Okay, let's pull this into the real world and look at the Grammaticality Judgment Task, or GJT. This is a super popular, albeit pretty controversial tool used to quickly measure a language learner's grammatical competence. In second language acquisition research, scientists absolutely love using this test to get rapid metalinguistic data. Basically, that's data on how well a student consciously understands the actual rules of the language. They simply show a learner a sentence and ask, is this grammatically correct? Yes or no? Sounds simple enough, right?
Which brings us to Section 4, the hot dog problem. The messy reality of measuring grammatical competency.
So, does a quick, rapid-fire test actually measure a learner's true language ability, or is it literally just measuring their cognitive processing speed? This is a massive methodological headache in the field. As researcher David Birdsong famously pointed out in 1989, pulling this kind of data from a quick test is a lot like cheap hot dogs. They are made up of meat, but considerable other ingredients as well. I love that quote. When a student answers a quick grammar question, are they actually utilizing deep, explicit knowledge of the language, or are they just guessing because their brain is totally overwhelmed? You might think you're measuring pure grammatical meat, but you're actually measuring their test anxiety, their processing limits, and their working memory capacity all at the same time. The whole shebang.
Think back for a second to Craik and Lockhart's levels of processing. Just to answer one single quick test question, a language learner has to perform a whole bunch of complex cognitive steps. First, they have to extract the semantic meaning, then actively hunt for structural flaws, and finally reflect on the complex internal rules of a foreign language. If you put them under a strict, ticking time limit, they just can't achieve that deep processing. They end up falling back on shallow intuition, which for a second language learner is incredibly unreliable.
Section 5. Time, Guidance, and Results. An experiment with Saudi EFL learners.
So, Dr. Sami Alanazi actually tested these exact boundaries. He gave 36 Saudi students a past tense grammar task and divided them into 3 specific groups to see if giving them the opportunity for deeper processing would actually change their outcomes. The groups were guided planning, semi-guided planning, and no planning. Now, initially, the test results were completely convergent, meaning, statistically, there was absolutely no significant difference between any of the groups no matter how they prepped. Whether they had 10 full minutes to plan with fantastic examples or literally just general instructions, their initial performance was essentially identical. The cognitive load was just way too heavy for instant results. It really showed researchers that these fast pop quiz-style tests might be highly invalid for measuring actual true understanding.
But the study didn't stop there. Alanazi retested those exact same students 8 weeks later. Why? To see if time, combined with that initial processing depth, actually made a difference over the long haul. What happens to that memory trace when the brain has had nearly 2 months to let it settle?
The results are absolutely wild. When tested 8 weeks later, the groups that had planning time and guidance saw massive gains, while the no planning group actually fell backwards. The guided planning group, the ones who had the chance to deeply semantically process the grammar rules with explicit examples, they saw a 6-point gain. Even the semi-guided group improved by 5 points. But that no planning group, the ones who were essentially forced to rely on shallow processing and instant rapid-fire reactions, they actually lost ground, scoring a -2.
Section 6. Rethinking Human Learning. Why Deep Processing Matters.
So, we've traveled from the theoretical architecture of human memory all the way back in the 70s straight into a modern classroom with Saudi exchange students. And the absolutely crucial point here is that whether you're looking at legacy memory models or modern language quizzes, simplistic tests just completely fail to capture the true depth of human learning. The brain is not a filing cabinet where data magically transfers from a short-term tray to a long-term drawer. Instead, learning is this profound, highly active process. When we test students rapidly, we're very often just measuring their cognitive bottlenecks. But when we give them the guidance and, most importantly, the time to extract real meaning, to truly achieve that deep processing, that is when actual, durable learning takes place.
So I'll leave you with this final thought. Knowing that your brain isn't just a simple filing cabinet, how can you ditch the quick cram and start deeply analyzing the world around you? If memory is simply a byproduct of the depth of your analysis, it is time to stop trying to force information into a mental box and start focusing on extracting the deeper meaning from everything you learn. Thank you so much for joining me for this explainer, and happy learning.